Welcome everyone. So this is the last talk before we go for lunch, right? So it's engineering custom diffusion workflows with ComfyUI, a developer guide by Shreya and Siddhi. Over to you.
I'm Siddhi Shreya. We both work at Zikhara AI. We mostly work with image models for e-commerce content generation. So Shreya will take over.
Hello. So before I start the talk, I just want to show of hands. How many of you have used image generation tools like DALI, ChatGPT, Midjourney? Great, a lot of so you guys have a lot of context. Um, that's a joke. So what's the common denominator when it comes to any image generation tool? Prompt. Do you guys agree? So if you want to generate something very specific, what do? You tweak words in your prompt, but it can only get you so far. So how do you generate something very specific? You need more control. So this tool helps you. It helps you bring out something very specific. So ComfyUI is a tool that lets you sort of tune key parameters and not just prompts. Sorry. Okay, so I'll just take you through today's agenda and what you should sort of expect. So we'll start with a little story, which is I promise it's interesting. Then we'll take you through applications. We'll look at the interface, core features. We'll compare it with other tools. So there were tools before ComfyUI came in, and there were tools after ComfyUI. We'll go through them. Then Siddhi will take you through a demo of the tool. Sort of, it'll be a little technical to give you a little deep dive, and maybe it'll encourage you to get started with this. And then we'll wrap up. Okay. How many of you have heard about stability, stable diffusion models? Yeah. So Stable Diffusion released in August 2022, and this tweet is from the then co-founder of CEO of Stability AI, Imad, and we sort of always trace back the start of image generation to this tweet, but I want to step back and briefly sort of give you a different perspective of how image generation came around, and it sort of it blowed up. So how did that happen? Okay, so stability did release this model, but around that time, a lot of companies were doing the same thing, and this company on the screen was also developing something around that time, and the weights of this model that they were about to release got leaked on 4chan. For the uninitiated, 4chan is sorry, 4chan is like Reddit but on steroids. Um, it got released, and you can imagine all a community of developers, tinkerers, artists came in, and they started to write guides on how to use these model weights, how to fine tune. They started making their own models. I mean, what is model? It's made up of data. So if you have a bunch of data that you want to create a model on, you can do that, and anybody with a GPU can do it. So a lot of spin-offs started to emerge, and one of the big ones was this um, sorry. Yeah, so a lot of spin-offs start to emerge, and this was the big one. So Waifu diffusion is trained on anime data and NSFW data. Um, so what I wanted to say is a lot of custom models are to emerge out of like all of this activity that happened on 4chan. And this phenomena is quite this is a side note, but this phenomena is very prevalent in technology adoption. A lot of fan communities sort of push the technical boundaries on what's possible in open source image generation, and then it sort of they also build the infrastructure needed for it, and then mainstream users benefit from that infrastructure. This is the website called Civit AI. This is, if you just, this is a very interesting. This is a very interesting website. If you go on this, you will find models. So anybody who's trained models can upload models on this, and you can also monetize your models. So this is where a lot of these NSFW models are to emerge, and okay. So Once you've got to Civet AI and you've got hold of these models, then how do you use it? You need a UI, and that's when automatic 1111 came in. This made it ridiculously easy for anyone to get started with a model if you have a GPU locally. And this is how the web UI started to look. And I'm sort of giving you a bit of a random context because I want to get to the tool and why this tool is important. Now, if you look at this UI, you'll see that you see at the top, if you can see, there is a stable diffusion checkpoint. That's where you load the model. Then you click on text to image. This is one sort of method. And then you put in your prompt. You can see that you can select a sampling method from the drop down, and you can toggle steps. You can toggle width and height, CFG. You know, there is a bunch of stuff on this UI, but what if you want to do something which is not on this UI? How do you solve for that? That's when ComfyUI comes in. ComfyUI started it started around Jan 2023 by this developer named Comfy Anonymous, who's not actually anonymous. He's quite famous now. Um, he built this workflow where you can build your own nodes and you can create this whole UI. And this is how it looks like. I'll just show you that interface in a moment. But this sort of became the most powerful open source node based application for visual generative AI right now. Okay, yeah. So ComfyUI, so what is the building block of ComfyUI? It is a node. But before I explain you what a node is, I'll explain you what is a workflow. A workflow is a series of steps that you connect using noodles. So this is the simplest example of a workflow. This is an image. You load an image, you invert the image, and then you preview the image. Each of this node has a Python backend, right? Each of this block is a block of logic. And I'll show you a simple implementation of this invert image to give you context on how you can build your own Python based nodes. What you see is you can define the input types, you can define the return types, and then there is a function you can see which is def invert. What this does is this node basically inverts any black pixel into a white pixel and vice versa. So what you do is, if you know, a color is made up of 3 channels: red, blue and green. So if you want to convert any of these, you subtract it from 1, and that's where you get a negative of a photographic pixel. That is what this function does. This is the easiest example I could pick from this is one of the core nodes in ComfyUI. This is a completely open source project, by the way. You can go check out this and you can see the examples and you'll see how easily you can build one. I mean, this is just like four lines of code. I mean, if you just look at the function, it's just 3 lines of code. So that's how simple it is to build a node. Now, you may say why node based, but you already looked at automatic 1111 and how the UI look like. It's sort of fixed. You have to deal with what's already built. You can't really build your own things, and it's frustrating for developers because sometimes, at least, especially in image generation, I feel you sort of you come across use cases for which there are no solutions already available, and then you need to build your own. So ComfyUI comes in like there. Now, why does ComfyUI matter? First of all, it's stateless. So every run is contained in itself. So like I showed you a workflow, right? You saw that there was a load image, there was invert, and there was output. You saw the output image. What if you wanted to send this workflow to your friend and they wanted to build something similar? What you would do earlier would be to download the JSON. By the way, the workflow downloads as a JSON and you send the JSON file to somebody. They load it up on their interface and they can look at that. Now what they've done is the output image that you got, they embed the output image with metadata of that JSON. So you don't even have to download a JSON. You just have to share the image, and that image is loaded with the information that you need to reproduce the same image. That is cool. That is very cool because there are so many settings involved when you're creating. This was just 3 nodes, by the way. There are workflows with over 50 nodes. How would you reproduce that sort of thing? So yeah. And I will get into inbuilt queuing and batch processing when I show you the interface. This is because I want you to know why you should listen to this and why you should go check it out. Content creation, of course. I don't know if you guys know, Netflix hires people now who do ComfyUI. You don't have to be proficient because this is a very new tool, but you are sort of a tinkerer. You like art, you like making videos. You've seen all of these AI generated ads, so Netflix hires. Creative technologist is a real career now. You have to Google. Rapid prototyping, very simple. I thought it was very obvious in the beginning because it is very easy to set up, and I'll show you how easy it is. Training LoRa models is also something. I think there were a few talks based on LoRa, so I'm sure you guys know about it. Then virtual try-ons and personalized visuals, all part of creatives. Okay, now let's go through the interface. Now, I want you to think about Figma. A free form canvas. You can zoom in infinitely, zoom out. You can pan it. You can drag and drop nodes, and then you can connect it with noodles. This is how the interface looks like. Then there are side panels. One of the panels is node library. I showed you the invert image ka node, right? So these are all the nodes on the left side, and all of them are neatly in folders. Likewise for models, you don't just download random models. You cannot put a variational autoencoder with a diffusion model. They need to be separated by folders because you're working at a time with maybe around 10 models. So you need that sort of categorization, and this is basically, I want to say that this is a very neat UI. Then this is a very standard menu bar. You can save a JSON, you can export a JSON, you can refresh the UI. Can you see the manager? The manager is very interesting feature. What it does is, this is like a butler which sort of brings you the models and nodes. I don't think I have mentioned that. I did say that you can build your own nodes, but you can publish your own nodes. So people can use your nodes to build workflows. But how do you find what other people have built? You can't go and search on GitHub. Manager helps you do that. It sort of collects all the nodes from all over the GitHub and gets you here, and you can search up. And you can download it. It's just a click of a button. And then history. This is where I was talking about batching. Now, can you see the image? It says 12.38 seconds. Say you have a setting and you have put the steps at 20 and you've got this image. Maybe you put the steps at 15. You want to see how much time it takes. So it's very easy to prototype with different settings and see which is the best results and pick that. And then download the JSON and you're done. And this is where you sort of save all the JSONs. The JSON, what I mean by JSONs is workflows, core architecture and capabilities. All core image generation and LoRa fine-tuning obviously happens on PyTorch, so you can expect that kind of speed. And like I said, all nodes are implemented in Python, so you can build your own nodes. Everything is Python, very easy to get started. And it works with all popular ML libraries, transformers, OpenCV, diffusers, and such. And like I said, it's very easy to install. It has version control. It is a very active repo, by the way. You can build and customize your nodes, like I said, and it is very community powered. Like I said, shareability is a big thing in this. You can share your outputs and you can reproduce them very easily. And like I said, there were tools that came before this, and I want to talk about a little bit. Back in 2023, after the stability and all of those were released, how would you run a model? You had to write a script, and then you had to change all these steps. You had to sort of always, every time you had to run, you have to change it manually. You have to keep a record of what you changed. It's sort of boring, and it's also very time consuming. So that's where automatic 1111 came in. That was the first. By the way, automatic 1111, people still use it. I'm not saying it's a bad thing, but it's sort of limited, and that's where ComfyUI comes in. And I feel the best thing about ComfyUI is the scalable learning curve. Even the most beginner person can get started because you can just go on the internet. Say you want to build a product photoshoot workflow. You type in product photoshoot workflow, ComfyUI, you get a bunch of JSONs, load it up on your interface, click run. That's a beginner level. And this supports both open source and closed source. So there are, by the way, Flux Context Pro is closed source, so you can have an API. ComfyUI supports that. Yeah, I think Siddhi will take over.
Hello, my name is Siddhi. I'll start with showing you a video of how a workflow looks like, and it's just a video of me building a workflow. You might not understand everything if you've not used Comfy before, so I would say just look at it. I will go into detail and explain everything later, but for now, just look at the video. This is how the interface looks like. If you want a node, you just type the name of the node, it comes up, and you can place it anywhere in the canvas. Um, I'll speed up a little bit. You can join all the nodes using this noodle kind of setup. You run the workflow and you get the output. So you can just look at this image. I will be explaining this workflow in detail. And along with that, I will also explain in general how image models work. So I think it'll be a nice like trivia. Um, okay. So I have the workflow in the mermaid diagram here. We'll refer to this from now on. So let's start with the first um, node. It's the load model node. In Comfy, it's called the load checkpoint node. So this is the node where you actually load your main image model that will actually do all the image generation in the workflow. Here it's Dream Shapers. So usually models like SDXL, Flux, these are the models that are trained on millions of images and they know how to go from a prompt to an image. So you load the model first. Then you would have seen the load model is connected to a node called load LoRa. So the load LoRa is responsible for loading a LoRa model. But why do we need a LoRa model when we already have a model? So I'll explain this with an example. Say you want to generate images of cars. So you can just train a model on images of different kinds of car, a big data set full of different types of cars. You train it. But what if sometime down the line you want to train, you want the model to only generate Teslas, no other car, just Teslas. So you can technically go back and retrain the whole image model, but that is considered very expensive and time consuming. Uh, also, yeah, it's very expensive and time consuming. So what can you do in the situation? So this is where LoRa comes into picture. LoRa is short for low rank adaptation, which is a fine tuning technique. So when you load a LoRa model, it basically plugs into the main model and steers the model to actually produce outputs like the input that it was trained on. So in this situation, you take a LoRa model that was trained only on Tesla images. So that's like 50, 60 images, and it will hardly be a file of like 60 MBs, which is very small for a model file. So you take the LoRa model file and you use it along with your base model, and it basically tweaks the attention layers of your base model so that the main model layers remain frozen and the LoRa layers actually steer the output of the image. So if you use a main model plus a LoRa model, you'll mostly get outputs. For in our case, we'll get Tesla cars instead of just any random car. Then you'll see that the LoRa node was connected to these two nodes called the clip text encoder nodes. So these two nodes, the clip is basically short for contrastive language image pre-training, which is a very fancy way of saying it's basically a translator that translates your text prompts into numerical embeddings that diffusion models can understand. So in the clip text encode node, you put in your prompts. In most cases, we have a positive prompt and we have a negative prompt. So the clip will convert all these text into numerical embeddings. So positive prompt, for those of you who don't know, you put positive prompts as guidance for the model to actually like follow the model will follow the positive prompts, and the negative prompt is everything that you don't want the model to follow. So you put keywords like blurry or low quality in the negative prompts. So now we have the model, we have the prompt. But how does the image generation start? So usually in diffusion workflows, we always start with something called as the empty latent. So the empty latent is basically like the canvas that your image generation process starts with. And in this case, it's like a 5 and 2, 5 and 2 canvas. But instead of a blank canvas, it'll look like this. So all empty latents look like this, and all diffusion models start with this. And then using your prompt as a guidance, it will denoise the image step by step to actually produce the output. So all diffusion models, this is like a basic uh, workflow for any diffusion model. Um, so now we know what load LoRa does, what load model does. We know what clip encoders do, what empty latent does. Now let me introduce you to the hero of this workflow, which is the K sampler. The K sampler takes all of these nodes that I spoke about as input and spits out an image. So it actually takes all the input, does the engineering, and gives you the image. So you can see these are all the inputs and this is the output. I'll tell you why this output is not called image and why it's called latent. But before that, let me explain all these controls because this will give you an insight into how a K sampler works. So let's start with the first control, seed. I showed you how a empty latent looks like, right? It was just a bunch of random points. But what if it was a different bunch of random points? So this is seed value, this number. So it's a bunch of random points. And this is a different bunch of random points. So usually in generating images, what we do is if we want to keep the prompt similar, we want to keep the text, everything similar, but we want the output to look a little different. What we can do is we can change the seed. So that will essentially change the beginning, the starting canvas of the image, and that will lead to a different output. So you can just keep changing the seed values if you want different outputs with the same all other settings. Um, the control after generate actually controls the seed. So here it's set to randomize. So for every generation, a different random seed will be generated. If you set it to increment, it will increment the seed value by 1 for every generation. If you set it to constant, it will remain constant, which is great for testing. The next is steps. So steps is basically how many times the model will actually denoise the empty latent image to generate the output. So if it's 20 steps, there'll be 20 denoising steps. So usually we say if there's more steps, there'll be more detail in the output. You'll understand the steps, the sampler and scheduler a little bit. They work a little bit together. I'll explain it in the sampler and scheduler. But before, let me come to CFG. So CFG stands for classifier free guidance, which is basically just how closely your model will follow the prompt. So if you keep the CFG to really low, like 1 or 2, the model will not follow the prompt very closely. And if it's set to a really high value, it will like hang on to each and every word in the prompt, which is something that you might have seen if you have experimented with image models. Yeah, now let's talk about sampler. So this is arguably the most important control in the K sampler. I told you how the model always denoises a image, but the denoising process is not random. It doesn't just randomly remove noise from a empty latent. It follows a certain algorithm, and which algorithm, it depends on the sampler. So this Euler sampler has a certain algorithm with which it will denoise the image. You use a different sampler, it will use a different algorithm to denoise the image. So usually people test with different samplers to see which one works the best for them. The scheduler, so this is an example of like 4 different samplers all running at different steps. It might look very similar to you, but you run it for 300, 400 steps, you'll see the difference. The scheduler works with the sampler. So sampler decides how the denoising is happening, but the scheduler decides how much denoising happens in every step. So normal scheduler, like linear scheduler, will remove equal amounts of noise in every step. Whereas there are schedulers like Keras, this scheduler, it will remove very little noise in the earlier steps and then it will aggressively start removing noise towards the end. And all of these have their specific algorithms for denoising, for removing the noise. Yeah, and the last step, denoise, this is a control that is only used in image to image workflows, and it is basically a parameter for how much image retention will happen in an image to image workflow. So if the denoise is set to very low, the input image will mostly be retained in the output. But if it's set to really high, like 1 is the highest value, then the model is free to like do whatever it wants, doesn't have to retain a lot of the input image. So we have all the nodes here. The K-sampler took the input and spit out the output. So I told you K-sampler does not spit out an image, but spits out a latent. Why? So diffusion models actually never generate raw pixels. They work in the space called latent space, which is basically a compressed representation, because it's much faster to do generations in latent space than it is to work with full resolution pixels. So all diffusion models work in this latent space, generate images, and then those generations need to be decoded and be brought into pixel space so that we can see them. So VAE decode is a node that does it. This takes the latent representation and actually converts it into pixel space so that you and I can see it with our eyes. But VAE decode needs a model for that. It's called the VAE model. And we use the load VAE node in the workflow to load that model. It's just like the load LoRa node, load model node. We just load a VAE model and give it to the decoder. And then the decoder takes the latent from K-sampler and gives us a output. So this node, the final node, is the save image. It can also be a preview image, and you can see the image. Usually it's in JPG and PNG format. Yes, so that was my explanation of the workflow, and I hope I gave you a good explanation on how that workflow works, and in general how image generation works. Uh, I think ComfyUI is a very powerful tool because it gives you a very visual way of understanding and making more image workflows. So, and also the biggest power is its modularity. You saw how every node has its own specific role. So you could swap out any node, you could add nodes, you could experiment, and that's how you basically just learn. So I suggest all of you to try ComfyUI once and give a uh, take your artistic spirit out and try image generation, even if you don't have any experience in it. Thank you.
Um, Hello.
Yes.
Yeah. Great session.
Where are
This,
you?
yeah.
Hi.
Hi. Yeah. So
Yes.
I have one question.
Yeah.
So you mentioned that that how many steps are
Yeah.
decided, right? Like, so
Yeah.
is there any limit that we define, or it is the scheduler that kind of automatically picks that how many steps should be there?
No. So steps is something that we define, but it's very much a play of experimentation. So you set, if I set like 40 steps, there is, and you set a specific scheduler. Certain schedulers might decide to use like the earlier steps, just the first 10 steps, very scarcefully, and just like do very little denoising, and then suddenly it will just get hurried and do all the denoising towards the end. Then certain schedulers behave in completely opposite ways. So the steps you only define, the scheduler also you only choose, but it's a matter of experimentation to decide what combination works the best for you.
Okay, and yeah, regarding that, like you mentioned that there are testing criterias as well. So are there any predefined testing criteria, or it just this play and experiment?
Do you want to take this?
Yeah. So there are no standard ways of testing image generations because image generation itself is very subjective. What we usually do is, if you want to do it at scale, you plug in a vision model, you give it very specific instructions on how you want it to be judged. Possibly you'll get evals, but that is it. It's very subjective.
Yeah. Thank you so much, guys. It was a great session. Thank you.
Thank you.
Thank you. Could you talk about how in-painting works with ComfyUI? Because a lot of times you would want only certain parts of an image to change and everything else to be exactly the same.
Yes. So for in painting, there are certain sort of tools that you can use. Common one is you can use mask the part of the you want to either in paint or out paint, and then you put nodes accordingly, and then you get the output correctly. But essentially, for in painting itself, I would say your whatever you want to do artistically would be, I mean, I can't give you a definite answer, but essentially tools like these only, like masking, you can prompt it, then there are certain nodes that let you draw and tell exactly where you want to make the changes. So I would say it's very subjective, but in painting is definitely something, if you want to explore, ComfyUI is the best thing to do in
Got
painting.
it. Thank
Yeah.
you.
Yeah.
Love the talk.
Just a comment on the previous question. There are, I think, some very specific LoRa's that are specifically fine-tuned for in-painting tasks,
Yes.
but you need to provide a mask.
Yes.
So if you were to say pick that particular LoRa which removes an object or something or enhances it, then that sort of helps you in paint better
Yes. Yes.
instead of using the whatever the default LoRa is.
Yes. Thank you. Thank you so much.